So I'm just going to do a quick overview of finding the distance between 2 points using the Pythagorean theorem, and then we'll also go ahead and we'll try using the distance formula, which is connected, just as a reminder. So the first thing I want to do if I'm going to do the Pythagorean theorem is I'm going to need to connect these two dots right here with a line. So this is the distance we're looking for, and we cannot just count diagonally. So I'm going to go ahead and make a triangle off of that, which is going to help me, and that way I have a right triangle, which I need a right triangle to use the Pythagorean theorem. So there's my right triangle. And then we're going to go ahead and we're going to count. And I have 1, 2, 3, 4. So this is 4. And this right here is 1, 2, 3, 4, 5, 6. This is 6. So if I want to use the Pythagorean theorem, then it would be 4 squared plus 6 squared. So this would be my leg A and this would be my leg B. And that equals the hypotenuse, which is C. So I'm going to go ahead and square it. So 4 times 4 is 16 plus 36 equals C squared. And when I add these, I get, 252 equals C squared. And then I take the square root of both sides. 52 equals the square root of C squared. And I get that this is the square root of 52. So once again, here's my triangle, 4 and 6. I use the Pythagorean theorem. This is done a little different because they are taking the square of this. If you see that, they're taking the square root right away. But as you notice right here, even though this is done a little differently, you will notice that it ends up being 52, the square root of 52 units. And then the square root of that is 7.21 approximately. And that would be units. So that's what this is, 7.21 units, but that's an approximation. The square root of 52 is the exact answer. And then you might want to check and see if you could simplify that. So if I want to see if I can simplify this further, which some of you might like to do, then I want to go ahead and I want to see if there's any perfect squares inside of here. So what I like to do is I just do a factor ladder. I'm going to divide that by 2, which gives me 26. And if I divide it by 2 again, I get 13, which is a prime number. 2 times 2 is 4, so this would be 4 times 13, which equals the square root of 4 times the square root of 13. The square root of 4 is a perfect square, so that's 2 times the square root of 13. And you may be asked to look for those kind of answers in your activity. So if you don't get it correct, it could be that there's a perfect square as one of the factors of the radicand. So now the Pythagorean theorem on the coordinate plane. So something you may be asked to do is to go ahead and graph your points and to figure out from there. So this one's a little different because as you graph these, you end up getting a triangle that's not a right triangle. So what are you supposed to do with that? Well, this is nice and vertical. So if I look at this side right here, it looks like I have 6 of them, but I'm going to split it in half with a line. And then I'm going to go ahead and put a 3 here and a 3 here. And when I count this way, I get 1, 2, 3, 4, 5, 6, 7. So there's 7 here. So I can take this triangle out and look at that triangle. And when I look at that triangle, it's going to give me this measurement. And here's 3 and here's 7. So I can do, if I make this A equals 7, and I make this B equals 3, I can go ahead and I can say, using a squared plus b squared equals c squared, or leg a squared plus leg b squared equals the hypotenuse squared, I get 7 squared plus 3 squared equals c squared. 7 times 7 is 49, plus 3 times 3 is 9, equals c squared. And then I'm going to take and add these two together, and I get 58 equals c squared. And then I take the square root of both sides. 58 equals the square root of c squared. And this right here is a good answer, but it becomes approximately 7.62. So this side right here is going to be the square root of 58, or 7.62. So to find the perimeter, we add the sides. So we discovered that the sides were approximately 7.62, 7.62, and then this measurement right here was 6. So we go ahead and we add those, and we get this answer here. Now remember, this is actually an approximation. It is approximately 21.24 units. And again, be looking to see if they want you to leave it in radical form, because if it was in radical form, this would be written not as an approximation. Now here we're going to look at a problem that you will probably see when you do your study island activity. And so you have an option, specifically a right triangle, and use the Pythagorean theorem. So 1, 2, 3, and then 1, 2, 3, 4. And so I can use a squared plus b squared equals c squared, or leg a squared plus leg b squared equals hypotenuse squared. If I make this equal to a and this equal to b, this would be 4 squared plus 3 squared equals c squared, or 16 plus 9 equals c squared. If I add those two, I get 25 equals c squared. Take the square root of both sides, and I get 5 equals c. So it's answer D. So there's another way to do it. We can find these points. This point right here is, point A is -3, -1. -3, -1. And point B is 1, 2. And if we make this is x and y, and I'm going to make this my second one and this my first one. So I'm going to use the distance formula, which says distance equals the square root of the second y minus the first y squared plus the second x minus the first x squared. And so this becomes distance equals the square root of, so we've got 2 minus -1, 2 minus -1, and that's squared, plus we have 1 minus -3 squared, and we get distance equals the square root of, this is 2 plus 1, so this is 3 squared, plus this is 1 plus 3, which is 4 squared, and so the distance equals the square root of 9 plus 16, which the distance equals the square root of 25, and the distance equals 5. So we got the same answer. So once again, it's D. So that is something you can do if you don't want to do if you do not want to do the Pythagorean theorem. You can also use the distance formula. Sometimes the distance formula is better. I think for this particular problem, it was actually easier to use the Pythagorean theorem. So this is what you're going to be doing in Study Island. Okay, so here we're looking at the distance formula again, and here it shows it written the other way around with the x's and the y's, and this is an example. So the formula gives the distance between 2 points, and it's just showing it formally, and then it has it here just to refresh your memory, so that's something you can use. And then here is another example plugging in coordinates and what problems can I solve with the distance formula. So here's an example where I have 2 points and they went ahead and wrote the distance formula. Again, I wrote it the other way around, and then you can plug in the coordinates. You get 8 squared plus 6 squared, 64 plus 36, which equals 100. Square root of 100 equals 10. Check your answer. What is the distance between the ordered pairs of 4, 2 and 8, 5? So you want to go ahead and try this and see what you get. Okay, so you're going to use the distance formula, and then you're going to plug in your answer. So I'm going to do D equals, I'm doing the y's first, and I'm going to do 5 minus 2 squared plus, and then I'm going to do my x's, and I'm going to do 8 minus 4 squared, so 8 minus 4 and 5 minus 2. I usually like to stack them so that I don't mix them up, and that would look like this, and then I have my x's here and my y's here, and then I could subtract down this way, and that's just to help me from getting confused, and you'll notice that it looks like I did it correctly. And so here we have distance equals the square root of 5 minus 2 is 3, so 3 squared plus 8 minus 4 is 4, so 4 squared, and the distance becomes equal to 9 plus 16, where distance equals 25. Oh, look, we got the same thing. And so D equals 5.